Hello viewers, a very warm welcome back to Reflux. In this video, I'll be covering detailed solution questions that came from the subject electric circuits in GATE 2025 electrical engineering. So basically 5 questions came from electric circuits, 2 of 1 mark and 3 of 2 marks, total 8 marks, which were almost easy to moderate. So let's start. In this video, we'll be covering detailed solution question number 18 from GATE 2025 electrical engineering from subject electric circuits. So 1 mark MCQ type. Question goes like, the IV characteristics of the element between the nodes X and Y is best depicted by. The circuit is given as, the options are given as A, B, C and D. Graphs are IV characteristics IXY versus VXY. IXY is the current through XY from X to Y and VXY is the voltage across XY. So let's move on to solution of this question. Very basic question actually, which can be solved by simply applying Kirchhoff's current law, KCL. As you can see in the given circuit at the node X, right? The node X. Applying Kirchhoff's current law, KCL. At the node X yields what? IXY equal to 1 ampere plus dxy by 1k or 1 kilo ohm. Right. Just simply line the Kirchhoff's current law equation at node X. Now, this in itself represents a equation of a straight line, as you can see, of IXY versus VXY with a y-intercept of 1 ampere and a slope of 1 by 1k, that is 1 m, 1 millisiemens. This is slope. And y-intercept is 1 ampere. So among the options given, so it matches with the option B, as you can see. Right, such that the slope of IXY versus VXY is a y-intercept of 1 ampere and a slope of 1 by 1k, that is 1 m, 1 millisiemens. So that's all for solution to this question. I have explained very basic question from electric circuits. It can simply solved by applying Kirchhoff's current law. Hope the solution is clear. I have explained the process solving. If you have any doubts or queries, please feel free to ask in the comments. And that's all for solution discussion. Thank you.
Hello viewers, moving on to the next question in the series of GATE 2025 electric engineering solutions from subject electric circuits. In this video we will be discussing the detailed solution question number 19, which is a 1 mark MCQ type. The question goes like, a nullator is defined as a circuit element where the voltage across the device and the current through the device both are zero. A series combination of a nullator and a resistor of value R will behave as a, options are given as A, resistor of value R, B, nullator, C, open circuit and D, short circuit. So let's move on to solution for this question. Pretty simple question actually. So let's first draw a nullator as it is given in the definition, which is basically a circuit element across which the voltage and current both are zero. Voltage across the device is zero and current through the device is zero, also zero. Voltage across the device is zero, so it's behaves as a short circuit, and the current through the device is also zero, so it's also an open circuit like that. Both voltage and current are zero for the nullator. So this is the circuit for the nullator as I have shown. Now let's draw the circuit that is required, the series combination of a nullator and a resistor of value R in series. Nullator and a resistor of value R connected in series. Okay. Now, as the nullator, this is the circuit diagram of the given element, right, as it is given in the question. Now the resistor is connected in series with the nullator, and as the nullator doesn't draw any current, it doesn't allow current pass through it, therefore no current passes to the series combination of the nullator and the resistor, as they are connected in series. Current should be same and it is 0, and the voltage across the nullator is 0. It is given as is given in the definition in the question. So as no current flows through the resistor, the voltage drop across the resistor is IR into R, or I into R, that is also 0, right? The voltage across the resistor is also 0 as there is no current flow through the resistor. So the net voltage across the given element will be the sum of the voltage across the nullator and the voltage across the resistor. As per the definition given, the voltage across the nullator is always 0 and the voltage across the resistor is also 0 because there is no current flow through it. So there is no voltage drop across the resistor. So the net voltage drop across the element is Vn plus Vr is equal to 0 plus 0 equal to again 0. So the voltage across the entire element is 0. And the current through the series combination of the nullator and the resistor of value R is also 0, because the nullator does not allow any current to flow. So the net combination of the nullator and the resistor of value R again behaves as a nullator, because the voltage and current both are 0, right? So the correct answer of the option that is matching is option A, so B, nullator. I hope the solution is clear. I have explained the approach, very basic to this basic question. If you have any doubts or queries, please feel free to ask in the comments. And that's all for the solution to this question. Thank you.
Hello viewers, moving on to the next question. This is a great video to electrical engineering solutions from the subject electric circuits. In this video, we will be covering the video solution of the question number 39 according to the master question paper in detail, which is up to 1 MCQ from the subject electric circuits. Question is given: the circuit from which the values of R and C are very large, the form of the output voltage for a very high frequency is best represented by. After that, it is given, 12 input is given, and the capacity factor is the output. Output voltage taken across the capacitor is given C. So we are given 4 graphs as the forms the output voltage. We need to choose the correct one. Let's move on to the solution. Basically, what we can do is we can do some frequency domain analysis. Okay. Frequency domain circuit capacitive impedance 1 by Fp. If you take the transfer function, what will you get? Let's solve 1 by Fp by 1 by Sc plus R. So if we simplify, we get 1 by R. Yeah. Right? Now, in the frequency domain, it will be d omega by dj. So you will get f with d omega. 1 by omega plus 1. Right? Now we will do one thing. So order omega by what number on the under root omega whole square plus 1. Right? As R square very large, At omega here, the frequency will have values of like 1 will be 0, which there will be omega 1. It is part of the frequency from the square level. 2 omega naught, 2 omega naught. No. Just as we do in the Fourier series. Now, as RC is very, very large, very large. Very large. So, this term for any formula, what we for DC, that is no DC component. So, well, it is no DC component. So, total DC gain here is what? We get what? DC gain is DC gain and what? But the input has a DC component. So whatever we do, that doesn't matter. We are only concerned with the gains for the frequency, which are integral multiples of the fundamental frequency. This frequency. So that 2, 1, 1, 2 omega naught, 3 omega naught, etc. For this frequency, the RC is very large. We multiply RC with omega naught. It will be still large. One can be negative in comparison to omega c cos square. It will be only equal to 1 by omega c. Now 1 by omega square will also be very large. So the gain will be negative. And as the frequencies go higher, it will still reduce. It will be increased for all frequencies starting from the fundamental frequency, and it will still go lower as we increase the frequency. Around the Fourier series. The Fourier series, the magnitude of the input voltage components will also reduce as the frequency increases. So automatically this will get to reduce. Finally, it can always be neglected so that at the output means that the output low ripple, very negligible ripple wala output voltage मिलेगा. So this corresponds to option. Very negligible ripple output voltage. Magnitude of the ripple जो है ना ये बहुत ही कम होता है. ओमेगा नॉट या आरसी वेरी large. Usually negligible. Ripple will be negligible. Most closest almost appropriate found the output voltage for the given conditions. So I hope the solution is clear. If you have doubts or queries, please do ask in the comments. So typical, tricky question. Based on some good analysis is required. Solve it based on Fourier series and frequency analysis and using the conditions given, RC with large, all those things. It may appear a bit tricky in the exam, so we have to tackle it carefully. But I have discussed in detail, and I hope the solution is clear and comprehensible. So that's all the solution. Thank you. Hello viewers. Moving on to the next question. This is a game electric initiation from objective electric circuit. In this video, we are going to solution to question number 52 of the maths question from electric circuit. This is a 2 marks MSQ type multiple choice questions, which may have more than one correct answers. So when the question is given, consider two coupled circuits having set inductances L1 and L2 that carry non-zero currents I1 and I2 respectively. The mutual inductance between the circuit is M with unity coupling coefficient. The stored magnetic energy of the coupled circuits is minimum at which of the following values of I1 by I2. The options are given as A minus M by L1, B minus M by L2, C minus L1 by M, D minus L2 by M. So let's move on to the solution for this question. net origin of the circuits is given by EP half L1 I1 square plus half L2 I2 square plus N I1. This is the expression for when we store the total magnetic energy of the coupled circuit. Now it is given N, we know that N is A2 segment, A is the coupled circuit. So given the theory, L1. So given 2, L1, 500 N square equal to L1. Right? Now for getting the minimum stored energy, magnetic energy of the coupled circuit, we need to differentiate the energy expression with respect to the I1 side. Right? What we do, what we will do is divide the whole expression by I2 square on both sides. So we will know what? This is what a function of I1 by I2 or unit square of I2 square. Square of I2. Unit square per unit square of I2. Function of I1 by I2. So we will differentiate with respect to I1 by I2. D of P by I2 is a function of I1 by I2. When this will get the extreme values, in this case maybe minimum. Most probably. Because differentiate this in what? 2 into half. Cancel. L1 by I2. There is no I1 by I1, so this is there. With one I1 by I1, derivative. For minimum value, we will do over this is 0. On solving, we get what? I1 by I2. I1 by I2 will get what? Minus. You can do that with minus n by L1. Right? And from here what we get? M by L1. Taking one and taking one in here. M by L1 equal to 2 by M. So we can replace M by L1 with L by M. Right? So what do we get? Minus M by I1 by 2 for minimum energy store, magnetic energy store in the coupled circuits, at minus M by L1 minus L by M. Matches the options, two options. One A and another one. Basically, we solved it using the principle of minimization of the stored energy and some expressions, basic expressions for energy. Hope the solution is clear. And that's all for this question. Thank you. Hello viewers, moving to the next question, the last one from electric circuits. Electrical engineering solutions from the electric circuit. The question number 57 to deal in this video and with the detailed solution to that. It is up to mark, we need type. The question is given as the switch S closes at t equal to 0. The time in seconds the capacitor takes to charge to 50 volt is round up to 1 terminal base. Circuit given RC circuit visibly. Need to find the time taken by the capacitor to charge 50 volts in seconds. The switch closes at t equal to 0. Second, let's move to the solution. At t equal to 0 minus, we go to forward state of the circuit. At This is open. So, and the capacity of steady state, steady state what happens? Capacity is open circuited. That's sure that we are here. Current was changed to the voltage was 75. It is 320. 3 amperes and 25 ohms. That is 75 volts. The voltage of the capacitor can be found in here. This group has 100 minus 25 volts. That is 100 minus 75, that is 20. Right. Now at t equal to 0 plus, just as this t greater than 0. The circuit will behave like this. T greater than 0, so it will close. Equal to 100 of volts. Type correct. Close to close. It will be 2 amps. This will equal after the time constant of the I into C, that is 5 into 2 into 5, and is 10 again. Right. Initial voltage is equal to 20 here, above, at equal to 0 minus. And the final voltage, infinity voltage, this capacitor taps to the connector, and we go on the circuit. Right. And this. And that works. 220. So it will be 100. Now we have the first order transit equation. T this is by 0 minus 2 power minus later. Right? This is information put 100. And this is 0 to 20. And tau is equal to 10 by 8. With this T T becomes what basically 100 minus 75 T to the power minus 0.1 T. And we need to find time in seconds at which 24. 24 is to 50. 100 minus 75 T to the power minus 0.1 50. On solving this, you will 75 1 minus 0.1 equal to 120. Right? Or T to the power 0.1 T equal to 75 upon 50. 1.5. So taking 11 on both sides, so this is for 11 of 1.1 and 11 of 1.5 version value. So after that, T will equal to 0 to 0.1 that will do 10. So 10 ln 1. We type this in the virtual calculator, we get the regular units come as 4.0. 4.1. 1 up to 1 decimal place, so the correct answer will be 4.1. The range is given as 4.0 to 4.1. So we obtain the time equal to the temperature which are 50 volts after the closing of the switch is 2 volt to 0 as 4.1 seconds. And I show the duty calculation. First finding the initial condition, then the final condition, the time constant, and applying the first order RC circuit equation. So to obtain the answer is 4.1 in time we will answer to. Hope the solution is clear and complexity. If the student doubts or queries, please ask in the comments. I would like to answer, and that's all for this question. I also will submit later service. Thank you.